Let us have some foundational discussions about composition of functions. We are given two functions y equals f of x and y equals g of x. The compositions are defined as follows. Let me give a name like hx, which is the composition of f with z. F composition gx can be written as also f of g of x. And another name, say uppercase hx, we are changing the function now. G composition f, that is also read as g of f of x. We'll take an example. Say f of x is 1 over x minus 8 and gx is 3x squared. And from algebra, you know the domain of these functions. We'll discuss later. Now, the composition of f of g of x, we are writing f of g of x is replaced by 3x squared, which is the new input for the function f. When we have f of x is 1 over x minus 8, now this x will be replaced by 3x squared. So this expression here on the right hand side is the composition of f of g of x. Now we'll change the other way. We are writing now g of f of x. So f of x is now replaced here, which is 1 over x minus 8. Now g of 1 over x minus 8. Now 1 over x minus 8, this is the new input for the function g. So then if you look at the function gx is 3x squared, so this x will be replaced by the new input 1 over x minus 8. And then we are getting 3 times 1 over x minus 8 squared. After simplification, you get 3 over x minus 8 squared. So these are the compositions from left side f and then inside gx and also g of f of x. Usually f of g of x and g of f of x are not the same. But we will check one example where they will be same and we have a new declaration for those two functions. We'll check in the next example. Now let us talk about the domain of the function f of x. As we see, the denominator has x minus 8, so which is not equal to 0. That means x cannot be equal to 8. So you can write an interval notation, negative infinity to 8 and then 8 to infinity for the function f of x. And g of x function is 3x squared, which is a nice polynomial function. So the domain is all real numbers, or in other words, you can say negative infinity to positive infinity. Later we check what is the domain of f of g of x. In this result, we see 1 over 3x squared minus 8. So we also need to say 3x squared minus 8 cannot be 0. And after simplification, you will find x cannot be equals plus or minus square root of 8 over 3. And then g of f of x, the last result we have here, 3 over x minus 8 squared. So in this case, x minus 8 should not be equal to 0. That means x cannot be equal to 8, which is same as the function of f of x. Next example, f of x is x squared and g of x is 3 e to the x. So same way we are writing f of g of x. G of x is replaced by 3 e to the x, which is a new input for the function f of x, defined as x squared. Now this x will be replaced by the new input 3 e to the x. And then if you simplify this one with the parentheses here, you get 3 squared, which is 9, and e to the x, and then exponent 2, meaning is you multiply 2 with x. So that gives you e to the 2x. This is the algebraic process. Next, g of f of x. Now we replace f of x by x squared. And this x squared is a new input for the g function. So we need to write 3 e to the, this x will be replaced by x squared. And that you see here. We take another example. F of x is x squared and g of x is square root of x squared minus 4. So the composition of f of g of x is f of g of x is input here. As you understand from the previous examples, very similar. We just need to do some simplification. Square root will cancel out with this square. So we get x squared minus 4. And then the next g of f of x is now f of x is x squared as defined here in the example. So then this x squared will replace now here on gx function. So you get x squared, and that square is also there. So this one we are getting square root of x to the 4 minus 4. Now, the special case that we mentioned in the beginning, we are going to see the composition and the connections between two functions known as inverse to each other. So I'm taking a function f of x is x to the 3 minus 1 and g of x is cube root of x plus 1. So let us look at the composition f of g of x. Same way. So we got, after simplification, we got x. The next portion g of f of x, same way, we put the new input in here, and that gives me cube root of x to the 3 minus 1 plus 1, as you see here. So this x for gx coming as a new input, x to the 3 minus 1, and that gives you cube root of, so this should be 3 here, cube root of x to the 3, that will make it x again. So I have a typo here. This is not x in this radical sign. It should be 3. Now we see f of g of x and g of f of x are equal, and they are all equal to x. That means these two functions are inverse to each other. So now let us look at the graph of these two functions together using Desmos. So this is the function here. I have the blue color. That is my function g of cube root of g of x, which is cube root of x plus 1, the blue one. And then the red one is x to the 3 minus 1. And then the line in the middle is green color. That one is y equals x, which is called the line of symmetry.